Welcome student, how are you? I am Dr. Maji, teach physics for NEET, mains and advanced. Now I will be discussing the free body diagram. Look at this diagram. We have to calculate acceleration of the wedge in this direction by considering it is a non-inertial frame and then considering the ground frame. In this case, we have to calculate the acceleration of this block along this direction by considering ground frame as well as non-inertial frame. Now student, focus this problem and I will solve this problem very easily, and this solution will be greatly beneficial for you. This my way of solution is very easy for you. Okay, now let's start. Look at this, considering ground frame. Suppose acceleration of this block is equal to a along this direction. So here decrease of length takes place and here increase of length takes place. Look at this, the decrease of length of this string is equal to increase of length of this string. Therefore, the acceleration of wedge along this direction A, so acceleration of small m along this direction is also A. Now as the block is on the wedge, so the block also has a acceleration along this direction. So with respect to the ground, M has two types of acceleration, one along this direction and other along this direction. Now these two acceleration resolve along the plane and perpendicular to the plane. Suppose this is the x-axis and this is the y-axis. Look at this, the component of A along this direction is A cos theta and along this direction is A sin theta. Okay, acceleration along the plane Ax equals to A minus A cos theta. Okay, so this becomes A into 1 minus cos theta. Okay, student. Now the acceleration normal to the plane AY equal to, look at this, A sin theta. Okay, now considering free body diagram along x-axis. Look at this, here force is mg sin theta, here force T, and acceleration along this direction is A into 1 minus cos theta. So what is the equation of motion? The equation of motion, this force minus this force equals to mass into this. Okay, understood? So this is the mg sin theta minus T, this equal to m into 1 minus cos theta. Okay, so this is equation number 1. Now considering forces normal to the wedge, that is along y-axis. Now look at this, here mg cos theta, this is the mg cos theta and this is the normal reaction in, and here acceleration, look at this, here acceleration is the A sin theta. So this force greater than this, therefore this minus this equal to m into this. Okay, now this is the mg cos theta, look at this, this is the mg cos theta minus n equal to m into A sin theta. This is equation number 1. Okay, sorry, this is equation number 2. Okay. Now calculate T and N from these two axes. Now T becomes, look at this, m into g sin theta minus A into 1 minus cos theta, and n equal to m into g cos theta minus A sin theta. Okay, now look at this, consider the forces acting on the wedge. Look at this, here tension T and here tension T, and normal reaction on the wedge by the block is N. Now look at this, the component of this N along the horizontal direction is N sin theta, and look at this, this is the T, and component of this T along this direction is T cos theta. So net force acting on it, look at this, this is the N sin theta and this is the T minus T cos theta. This equals to mass into acceleration. Look at this, this is the N sin theta towards right, T towards right, and component of T cos theta towards left. Okay, understood? Now we have to put N and T from the above two equation. Look at this, here N sin theta and this is the t into 1 minus cos theta, and this is the m into a. Look at this. Here n equals to, look at this, m into, look at this is the m sin theta into g cos theta minus a sin theta. Okay. Now look at this t. Now plus t equal to, look at this, 1 minus cos theta into m. Here this is the g sin theta minus a into 1 minus cos theta. This equals to mass into acceleration. Now look at this, the term containing g. Now look at this is the m into g. Here sin theta cos theta, and this becomes, look at this is the m into g, and this is the, look at this is the sin theta and minus sin theta cos theta. So look at this term cancel out. Now term containing a, look at ma plus small m a into 1 minus cos theta whole square, and here small m a into sin square theta. So this is the sin square theta. Now look at this is the 1 minus 2 cos theta plus cos square theta plus sin square theta. Okay. Now look at this is the a into m plus 2m into 1 minus cos 1 minus cos theta. Okay. Now look at this, here only mg sin theta, and here a into, look at this, here a into m plus 2m into 1 minus cos theta. So a becomes, look at this, here a becomes, here mg sin theta divided by, look at this, m plus 2m into 1 minus cos theta. Okay, understood? Now this problem can be solved with the help of non-inertial frame. You know that when wedge has acceleration along this direction is a, the acceleration of the block is also a along this direction. Okay. Now as the wedge has acceleration a, so it is a non-inertial frame of reference of acceleration a. So pseudo force acting on small m, look at this is the mass into acceleration of the non-inertial frame ma, and directed opposite to the direction of acceleration. Okay, student? Now look at this, the forces acting on it here, look at this is the, look at this is the force mg sin theta, and look at this force is mg cos theta. Okay, and now this is the normal reaction n, and the component of ma along this direction, this is the ma cos theta, and here this is the ma sin theta. Now look at this, suppose this is the x-axis and this is the y-axis. Look at this. Now considering the motion along the x-axis, now net force acting on it, this plus this, and along this direction is the tension T. So resultant force, look at this is the ma cos theta plus mg sin theta minus T equal to mass into acceleration. Understood? Now here T equals to, look at this, here T equal to mg sin theta minus ma into 1 minus cos theta. This is equation number 1. Okay. Now look at this, with respect to the wedge, m has no acceleration along the y-axis. That is, the wedge has no acceleration normal to the plane of the wedge. Now here forces acting on mg cos theta, here normal reaction n, and look at this is the ma sin theta. So force along this direction and force along this direction should be counterbalanced. So look at this becomes n plus ma sin theta equals to mg cos theta. Okay, so n becomes, look at this, mg cos theta minus ma sin theta. This equation becomes equation number 2. Okay. Now look at this. Considering the forces acting on the wedge, look at this. Here n sin theta along this direction, t along this direction, and component of this along this direction is t cos theta. Okay, this is the t cos theta. Now look at this. This is the n sin theta plus t minus t cos theta. This equals to mass into acceleration. Okay. Now put the value of t and n in the above equation. We easily calculate the acceleration a. Now look at this. Putting the value of n here and putting the value t here, we can get this result. Now considering the term containing g. Now look at this. The term containing g is here and term containing g is here. So look at this. This is a mg and here sin theta cos theta. This is the plus sin theta and minus sin theta cos theta. Okay, look at this. So look at this, sin theta cos theta cancel out. Now we considering the term containing capital A. Now look at this. This is the A, so this is the capital M. Now here the term containing here. So this is the, look at this. This is the m sin square theta. Okay. Now look at this, the term containing this here. So this is the also m into 1 minus cos theta whole square. Okay. So this becomes a into m plus 2m into 1 minus cos theta. Okay. So look at this, acceleration a becomes, look at this, acceleration a becomes, look at this, mg sin theta divided by, look at this, capital M plus 2m into 1 minus cos theta, and this equals to a. Okay. Okay, understood? Look at this. This is a wedge block system. The block is connected by a string here. Look at this. Now we have to calculate acceleration of the wedge. Suppose acceleration of the wedge a along this direction. Here decrease of length is proportional to a, and here decrease of length is proportional to a cos theta. So look at this, the increase of length here is also, so here increase of length proportional to a plus a cos theta. So if acceleration along this direction is a, so acceleration of the block is a plus a cos theta. Okay. Now look at this, as now with respect to the ground frame, this block has also acceleration along this direction, and this acceleration is a. So look at this, the block has two acceleration. Look at this, one along this direction and other along this direction. Look at this, here theta equal to 60 degree and here theta also 60 degree. Suppose this is the x-axis and this is the y-axis. Look at this, this is the x-axis and this is the y-axis. So look at this, acceleration of the block ax, this is the a plus a cos 60 degree, and component of this acceleration along this direction, this is the a cos 60 degree. So this is the minus a cos 60 degree. So this is the a. So acceleration of the block along the plane, that is along the x-axis, is only a. Now acceleration of the block normal to the x-axis, that is the y-axis, so this becomes a sin 60 degree. So ay equal to, look at this, ay equal to sin 60 degree, a sin 60 degree. So this is the root 3 by 2 into a. Now the forces act, now with respect to the ground frame, the forces acting on 2 kg, look at this, the forces acting on 2 kg, this is the mg sin 60 degree and this is the tension T. Okay. Now equation of motion along the x-axis, this is the 2 into g into root 3 by 2 minus t equal to 2 into a. Now we can get t equals to, look at this, this is the root 3g minus 2a. So this is the expression of tension in this frame. Now considering motion normal to the x-axis, that is along y-axis. Now forces here, this is the 2 into g into cos 60 degree. This is the normal reaction n, and acceleration along this direction, look at this, root 3 by 2 into a. So look at this force minus this force equal to 2 into a. Understood? So look at this here, 2 into half, cos 60 half minus n, and this equals to 2 into root 3 by 2 into a. So look at this is the g minus n equals to root 3a. So look at this, n becomes g minus root 3a. Okay, understood? So this equation, look at this equation becomes equation 2, and this equation becomes equation 1. Now forces acting on the wedge, look at this, the horizontal component of normal reaction n is n sin theta, tension T along this direction, and component of this tension T cos theta along this direction, and finally component of this tension along this direction. So four forces acting on the wedge. So resultant force becomes, look at this is the n sin theta, this is the T plus T cos 60 degree and minus T cos 60 degree, this equal to mass into acceleration. Now this is the n into root 3 by 2 plus T, and this is the 8 into a. Now putting the value of n and T in this equation. So look at this is the root 3 by 2, this is the root 3 by 2 into n g minus root 3a, and T equals to, look at this is the root 3g minus 2a, okay, equals to 8 into a. Now the term containing g, look at this, the term containing g is here and here. Look at this, so g becomes, look at this, root 3 plus root 3 by 2, and look at this, the term containing a, look at this is the 8a, this is the 2a, and look at this minus this, so this is the 3 by 2a. Okay, now look at this becomes 3 root 3 g by 2, and this becomes, look at this is the 8 10 23 a by 2. Okay, so look at this, a equal to root 3 root 3 g by 23. Okay, understood? The problem can be solved considering the wedge as a non-inertial frame. Now suppose action of the wedge a along this direction. So decrease of length in this string is proportional to a, and this angle is 60 degree. So decrease of length is proportional to a cos 60 degree. Now the sum of decrease of length is here and here is equal to increase of length of here. So acceleration of it is equal to, look at this, a plus a cos 60 degree. So this becomes 3a by 2. Okay. Now look at this. The wedge is a non-inertial frame of acceleration a. So pseudo force acting on it is ma directed opposite to the direction of acceleration. Now m equal to 2, so this force is 2 into a. Now component of this force is, look at this, 2a cos theta along this direction and 2a sin theta, 2a sin 60 degree along this direction. Okay, so look at this. Now the equation of motion along the plane, look at this, here forces acting is 2g sin 60 degree, and here forces is T. Now look at this force plus this force minus this force equal to mass into acceleration. Okay, now look at this is the 2g sin 60 degree root 3 by 2 plus 2a into half, and this is minus T equal to 2 into, this is the 3a by 2. Understood? Now look at this. This is the root 3g plus a minus t equal to 3a. So look at this, t becomes, this is the root 3g minus 2a. So this is equation number 1. Okay. Now look at this, as it is a non-inertial frame, so 2 kg block has no motion normal to the plane of the wedge. Now forces acting normal to the plane of the wedge, this is the 2a sin 60 degree, this is the n, and here component of weight is 2g cos 60 degree. So net force along this direction is 0. So look at this, this is the 2 into a into root 3 by 2 plus n, and this is the 2 into g into half. So look at this, the n becomes, look at this, 2 to cancel out and 2 to cancel out, this is the g minus root 3a. Okay. So this is equation number 2. Okay. Now considering the forces acting on the wedge. The forces acting on the wedge is T along the horizontal direction, and component of T cos theta along this direction, and component of T cos theta along this direction, and finally the horizontal component of normal reaction n sin theta along this direction. So look at this, considering the equation of motion, look at this, this is the t plus n sin 60 degree plus t cos 60 degree plus minus t cos 60 degree, this equals to 8 into a. Okay. Now look at this and this cancel out. So t plus root 3 by 2 into n, this equals to 8 into a. Now putting the value of t and n in this equation, look at this, this is the root 3g minus 2a plus root 3 by 2 into g minus root 3a equals to 8 into a. Okay. Now look at this, now considering the term containing g. Look at this, here g and here g. So g equals to root 3 plus root 3 by 2, and consider the term containing a and a. So look at this, this is the 8a, look at this plus 2a, and this is the 3 by 2a. Look at this, this is the 3 root 3g by 2, and this is the 23 by 2a. Okay. So look at this, a becomes 3 root 3g by 23. Understood? Thanks for watching this video. I hope this video will be understandable for you, and this video is very important for advanced preparation. I hope this video will be very beneficial for the advanced aspirant. Please like, share and comment on this video. If you are new, don't forget to subscribe my channel and hit the notification bell so that you can't miss a video. Okay.